Section 6.3 is on binomial radical expressions. So if we are adding and subtracting radical expressions, the indices and the radicands have to be the same. And to do that, to add or subtract those, we're going to combine what looks like the coefficient in front of the radical expression. Here's an example. So a times the nth root of x plus b times the nth root of x is equal to a plus b times the nth root of x. Same thing with subtraction. So for example, 3 times the square root of 5 plus 6 times the square root of 5. Combine the numbers in front. 3 plus 6 is 9, so my answer is 9 square root of 5. But here's a couple of cases where it doesn't work. So if I have the square root of 2 and the cube root of 2, notice that they have different indexes, and then the square root of 2 plus the square root of 3, they have different radicands. Those expressions cannot be combined further, and we say that they are in simplest form. If a single radical expression can be simplified, we want to do that first before adding or subtracting. Let's take a look at a couple examples here. Number 1 is 14a times the square root of 7bc plus 5a times the square root of 7bc. Notice the indexes are the same, they're both square roots. My radicand's the same, 7bc for both of those, so I just combine what's out front here. 14a plus 5a is 19a times the square root of 7bc, and that's my final answer. Number 2 has the cube root of 250 plus the cube root of 54 minus the cube root of 16. At first glance, you might say these can't be combined, even though the indexes are the same, the radicands are different, but I need to see if I can simplify each of those individual expressions first. So I'm looking for perfect cube factors, okay? So for 250, it's going to be 125, which is actually 5 to the third power, and 2. For 54, it's going to be 27, which is 3 to the third power, and 2. And 16 is 8 times 2, and 8 is 2 to the third power. So cube root of 250 is going to simplify to 5 times the cube root of 2 plus cube root of 54 is going to simplify to 3 cube root of 2 minus cube root of 16 is going to simplify to 2 times the cube root of 2. Now notice that my indexes are the same, my radicands are the same, so I can just combine the numbers out front. So 5 plus 3 minus 2 is 6 cube root of 2. And that's my final answer. To multiply two radical expressions in binomial form, we're going to use a method we've used with other binomials and quadratics. We're going to FOIL. So to simplify each expression here, I'm just going to FOIL this. So 1 plus 2 square root of 7 times 4 minus 3 square root of 7. Multiplying my first is going to give me 4. Multiplying my outer is going to give me a negative 3 square root of 7. Inner is going to give me 8 square root of 7. And outer is going to give me a negative 6. And then remember, square root of 7 times square root of 7 is just a 7. Okay, that's going to turn into a negative 42. And now I can combine these because they have the same index and the same radicand. So this is going to give me a negative 38 plus 5 square root of 7. Number 2 here says 5 plus 3 square root of 2 times 5 minus 3 square root of 2. Let's go ahead and FOIL. First is going to give me 25. Outer is going to give me a negative 15 square root of 2. Inner is going to give me a positive 15 square root of 2. And last is going to give me 3 times 3 is a negative 9 times square root of 2 times square root of 2 is a 2. And that's going to turn into a negative 18. Now, notice that these two terms right here are going to cancel each other out. So basically what I'm left with is 25 minus 18 for a final answer of 7. Okay. Notice that my inner and my outer canceled out. Notice that they're actually very similar. They both start with a 5 and they both end with a 3 square root of 2. It's just one is a plus and one is a minus. So in this case, I don't really have to FOIL. I just have to FL. Which brings us to something we're going to use to rationalize the denominator of a radical expression that has a binomial in the denominator. We're going to multiply the entire expression by the conjugate of the denominator. So I'm going to have 11 over 6 plus the square root of 3. And I'm going to multiply that, use the same trick kind of that I used up here in number 2. Okay, notice the same numbers, just one's a positive and one's a negative. Here I have a plus, so I'm going to do a 6 minus square root of 3 times 6 minus the square root of 3. What that means is I'm going to be able to get rid of or cancel out my denominator here. So I'm going to leave this like this for now. 11 times 6 minus the square root of 3. And then on the bottom, I'll go ahead and go through all of the steps. My first is going to give me 36. My inner is going to give me 6 square root of 3. My inner is going to give me a negative 6. Outer is going to give me a negative. Inner is going to give me a positive. It doesn't matter. I know what's going to happen there. And then square root of 3 times a negative square root of 3 is a negative 3. Remember, those are going to cancel out. I could have saved myself some time because I knew that was going to happen. Didn't have to actually do that. So I have 11 times 6 minus the square root of 3 over 36 minus 3 is 33. I can simplify a little further here. This 11 becomes a 1. And this becomes a 3. So my final answer is 6 minus the square root of 3 over 3 for a final answer. So in this section, we took a look at how to deal with binomial radical expressions, how to add and subtract expressions, and then how to multiply two expressions, and how to rationalize a radical expression that has a plus or a minus in the denominator, and how we multiply by the conjugate to get rid of that.